Right, so we have a question asking to find the area of a sector using polar coordinates. So we have two shapes here, if you can tell just by looking at it. So we have a shape C1, which is a little bit like this. So C1, and that's dictated by this equation, 1 plus sine theta. And then C2, which is like this, just the bigger one, which is dictated by 3 lots of 1 minus sine theta. So this is C2. And what do we need to do to find R? Well, firstly we need to describe some boundary conditions at where the points meet. So if we equal them to each other, it's going to be at this location and this location. That's going to set boundary conditions. And then we need to find this area, so all of C2, and then subtract it from C1. No, sorry, subtract C1 from C2, and we'll find the area R. So firstly, I thought it made more sense to first calculate area C2. So this space, the entire thing. Then really we're just trying to find the area of these bits and then take away the entire area of C1. So C2 is 3 lots of 1 minus sine theta. So R equals, what's the area? How do we find the area of a sector using polar coordinates? Well, A equals a half of the integral of R squared times d theta. So we're going to use that formula, which is in the formula book. And then firstly, to define our boundary conditions, we need to equal C1 and C2. So we're going to say that 1 plus sine theta equals 3 minus 3 sine theta. I'm just expanding the brackets there. I'm going to grab my calculator. We're going to need to do some trigonometry. So we have 4 sine theta, if we rearrange this, equals 2. So sine theta equals 1/2. So theta equals the inverse sine of 1/2, which is either, let's see, pi over 6, or pi minus pi over 6, which is 5 pi over 6. If you don't know how to get that, you should revise. Literally, well, you should, because you do it for further maths, but you should know that. But you should revise real maths and trigonometric identities, probably. But anyway, so these are going to be our boundary conditions. So between 5 pi over 6 and pi over 6. So R is this, so we're going to square this. So we're going to equal a half of 5 pi over 6 pi over 6 of, we're just going to bang this whole thing in brackets to begin with, all squared times d theta. That's going to equal 9 lots of, and then what's this squared? Well, 1 minus 2 sine theta. I'm going to skip steps because you guys are doing further maths, and this is, otherwise it'll take so bloody long to do. Plus sine squared theta times d theta. Here I just expanded this because this is 1 minus sine theta squared. So now we have a quadratic. So we're going to take the 9 out because it's a factor. So this is going to go to here. Times the integral of the middle, which is 1 minus 2 sine theta plus sine squared theta dot d theta. Oh no! How do we integrate sine squared theta? Well, we use the power reduction formula, which I've done like 1 billion times already, so you need to watch another video. I'm pretty sure it's in every other example I've ever shown, because you always have to end up trying to integrate a square. But this is just a half minus a half cos 2 theta, and you basically use this big thing, which is a minus b. You know this one? And then sine A, sine B. That's identity given to you, and then you can basically say that there's two lots of these in the middle, so you get 2. And then you get some squares, and then you rearrange, and then you get this, which is. I just said go and watch one, and I explained it 2 seconds later, and that's the worst integral I've ever written. 1 minus 2 sine theta plus a half minus a half cos 2 theta times d theta. Now we need to well, first we can clean it up a tiny bit, which we're going to say that 1 plus a half is 3 over 2, because that's 1.5 minus 2 sine theta minus cos 2 theta over 2 times d theta. Now we can integrate this bad boy. So this equals 9 over 2 lots of 3 over 2 theta minus 2 sine theta goes to cos theta, I believe. I think. Let's use a little trick, eh? Cos theta, baby. Because you have to go up the opposite way of that little ladder. Minus cos 2 theta over 2 goes to minus sine 2 theta over 4. Bang. Boundary conditions. 5 pi over 6 pi over 6. What do you know about this, huh? Well, we're just going to sub in a bunch of shit. So 9 over 2 goes to big brackets, little brackets, 3 over 2, 5 pi over 6, plus 2 cos 5 pi over 6, minus sine of 2 times 5 pi over 6 over 4. And then we're going to minus under it, so we run out of space. Big brackets, 3 over 2 pi over 6. So now we're going on the lower boundary. Because we always do the upper boundary minus the lower boundary. Plus 2 cos pi over 6 minus sine 2 times pi over 6. Oh my god, over 4. Bang, big brackets. So we've got 9 halves, or 4.5 times that massive thing. So we're going to rub out everything we've ever written. By the way, I'm not going to do it all in this one. I'm just going to work out the area of C2, and then in the next part I'm going to work out C1 and then take them away from each other. But maybe you can do that on your own. Oh, fuck. Fuck. I just rubbed it out. Well, let's remember what it was. It was 9 over 2 of 3 over 2 lots of 5 pi over 6 sorry guys. Hoping you enjoy me write out shit for too long. Brackets the whole thing, and then we're going to minus it all, and I just wrote out the same thing twice because I rubbed it out. That's 2 times 5 pi, which is 10 pi over 6, right? We could be cooked. I hope this is right. So now this is 9 over 2. And then we're going to start, so we're going to work out what the first bracket is. So 3 times 5 is 15 pi over 12. 2 cos 5 pi over 6. Is minus root 3. Sine 10 pi over 6 minus sine 10 pi over 6 is plus root 3 over 2. That's the first one. Try and fit in the next one. So we're minusing this actually. So that's 3 pi over 12. Right. 2 cos pi over 6 is root 3. And then minus sine 2 pi over 6 pi over 3 is minus root 3 over 2. Wow, look at this. We're making progress, baby. So, we write this all out, expanded in this bracket. We have 15 pi over 12 minus root 3. And I bet no one's watching this part of the video because you probably know what you're doing now. But I'm doing it anyway. Minus 3 pi over 12 minus root 3 plus root 3 over 2. Now, what can we deduce from this? We're going to separate the surds and the non-surds, the ones with the pi in it. So 15 pi over 12 minus 3 pi over 12 is pi. Which is good. That's a good sign that you're doing something right when you get nice normal numbers. Minus root 3 plus root 3 over 2. Minus root 3 plus root 3 over 2. It's minus root 3 over 2. I probably should have known. Probably should have guessed that one. And then minus root 3 plus root 3 over 2. I fucked something up. I know what I fucked up. Don't tell me. And that is because this shouldn't be root 3 over 2, but that would be minus root 3. Something sus is going on. Don't you hate when maths is sus? Where did root 3 over 2? Guess what I did, bitches? You should divide it by 4. I didn't divide it by 4. So this is minus sine 10 pi over 6 root 3 over 2 divided by 4. So this is this over 4, which is over 8. And this is also over 8. So this is over 8. And this is over 8. And this is... No, I'm not right. So now we have minus root 3 plus root 3 over 8, which is 7 minus 7 root 3 over 8. And then we're minus root 3 plus root 3 over 8, which is minus 7 root 3 over 8. So now this is minus 7 root 3 over 8 minus 7 root 3 over 8, which is minus 7 root 3 over 4. I'll get rid of this bottom line, baby. And then this is 9 over 2 times that. 9 over 2 pi minus 9 times 7 is 63 root 3. 2 times 4 is 8. Boom. C2 equals 9 pi over 2 minus 63 root 3. So next time we're going to start off with C2. We're going to work out C1, which shouldn't take as long, and then we're going to do some subtraction cool stuff and fuck it up, baby.